Hello everyone, this is going to be a short video introducing you to the topic of rays. So we've previously mentioned that light can be considered a kind of wave, and you can see here we have a candle. It's emitting waves of light. You can see each of these circles here represents a wave crest propagating outwards as a circle from our central source. The wave model of light is really useful. It can predict a whole lot of different things about how light behaves in particular situations. But for a lot of everyday situations, it's actually more complicated than we really need. So if you were to ask yourself, well, what does this candle look like if we saw its reflection in a mirror? Or what does it look like if we view it through a lens? It's a bit hard to answer just by looking at the waves. So instead, we're going to replace this series of concentric outward propagating circles with a whole lot of arrows. Okay, so you can see they're coming out from the source in every direction. We call these arrows rays. Now, rays behave in a few different ways. They always travel in straight lines when they're not interacting with anything. If two rays cross each other's paths, they just continue on through and they don't even care. They just move on as if nothing's ever happened. Technically, if you've talked about interference before, the point where they overlap, they will add together, but after they've done that, they move on as though nothing's ever happened. When it comes to interacting with matter, there are a few different things they could do. So here's our new medium of interest. You can consider it a big pane of glass or something like that. One thing that might happen when a light ray hits the surface of this medium, it might bounce off, which we call reflection. Another option it has when it strikes that surface is it could be transmitted into the medium. And you can see at the point where it's transmitted into the new medium, it will actually bend a little bit, which we call refraction. Other options that our light ray has, when traveling inside a medium, our light ray might be absorbed by the medium and essentially disappear. It gives its energy up to the particles that make up the medium. Alternatively, while traveling in a medium, it could interact with a particle and be scattered. So it moves in one direction, and then it's scattered, and it moves off in another direction. We're going to leave these second two aside for the moment, and the next couple of videos will focus on reflection and refraction. Now, let's consider where our light comes from. So imagine we have a single point source of light, like a very small light bulb. It's pretty straightforward. Light rays are just going to come out in every direction all at once. Now, we've got quite a few light rays here, but we haven't even drawn all of them. Really, they should be in every single direction, like an infinite number of arrows. But it's usually not going to be necessary to draw all of those. This is all well and good for a single point source of light. What about a real-world object, like a tree? It's not creating its own light. It's just reflecting the light that struck it. And it's not a single point source. It's quite large. It occupies a fair bit of space. So let's consider a single leaf. It's going to reflect the light that hits it in all directions, like a point source. But then we might consider a point on the trunk. It's also going to emit light in every direction, like a point source. You can quickly see that if we were to draw an infinite number of rays for an infinite number of point sources for the whole tree, it's quickly going to become unmanageable. So what we usually do is we pick a few select points and we draw just a few important rays. And we can work out what all the other infinity rays are going to do by thinking what would happen in between each of these steps. In fact, when we're doing optics, we use even simpler objects than this. The most common one would just be a single arrow. The point of the arrow represents the object, and we'll just select a few rays, principal rays, coming out from that object, and we can work out what the rest of the rays do from working out what these ones do, and we can work out what the rays on the rest of the object do by considering what the rays from the top point do. So this is, like I said, this is just a really quick intro. Hopefully this gives you a good idea of what rays are and how they behave. We're going to move on in the next video to ray tracing and ray optics. So I'll see you there.